Let's take a minute and remember how inverse functions worked. So, if f of x was equal to take a number and add 5, what is the inverse or the opposite of that? Well, f inverse of x would be take a number and subtract 5. Undo what you just did. Another way to think about it is that inverses switch the x's and y's. So if I plug in an x of 7 into g and the answer y that comes out is 12, what does g inverse do? Well, g inverse of 12, that y, when I plug it into the inverse, the answer that is supposed to come out is 7. Okay, switch the x's and y's. Now, what if we put this in a trig function? How does that work? Well, sine of 30 is 1/2. We know this from our unit circle. So what would sine inverse of 1/2 be in degrees? Well, the angle 30 degrees. So we have a moment here where we're kind of thinking about what is an inverse trig function. And this is where people get a little confused. Notice that when we have a sine function, the thing we're plugging in is an angle, and the answer coming out is a number that has no signs on it or anything. It's just a number between -1 and 1. So in a sine function, we're plugging in an angle, and the answer that comes out is a number between -1 and 1. So when I flip this and I do an inverse function, what are we doing? We're plugging in a number between -1 to 1. And we're asking, what is the angle that has a sign of this number? So we plugged in a number 1/2. The answer that comes out is the angle whose sign is 1/2. So the answers y that come out of an inverse function is an angle. So this is our tripping spot number 1. A lot of students see this and they go, oh, I'm going to plug an angle into a sine inverse. That's wrong. You plug a number into sine inverse that is the sine, cosine, or tangent of something. And what comes out is the angle that has that number as the sine or cosine or tangent. Okay. Second tripping spot that comes up is that when we start thinking about the domain and range of inverse trig functions, it gets a little wonky. So let's think about the domain and range of sine. If you look at the graph of sine, it goes infinitely to the left and infinitely to the right. So the domain of sine is -infinity to infinity. But the range, if we look, the highest it goes is 1 and the lowest it goes is -1. So that range is very small on the y-axis. So we get a range of -1 to 1. We get basically the same thing from a cosine graph, because remember, cosine is just a sine graph that's shifted around a little bit, but it's basically the same thing. Now, tangent is a whole different ball wax. Here is a tangent graph. So you can see the domain actually has a whole bunch of asymptotes in it at multiples of pi over 2. So the domain of this thing is crazy. But if we just kind of focus in on this middle guy, the domain is basically -pi over 2 to pi over 2 and then multiples of that. So we're going to put in a sort of shifted down domain of -pi over 2 to pi over 2. But the range that came out of this one was really big, wasn't it? We go all the way down to -infinity and we go all the way up to +infinity. So the range is going to be -infinity to +infinity. Okay, this is a little crazy looking, and this is going to cause us a little bit of a problem. Remember, inverses switch x's and y's. Domain is what letter? X. Range is what letter? Y. So when we say inverses switch x's and y's, that means that the range of sine inverse comes from the domain of sine, and the domain of sine inverse comes from the range of sine. So what is the domain of sine, cosine, and tangent? Well, -1 to 1 is what we can plug in. Those are things that have an angle that has that as a sine. Cosine will be the same. But remember, tangent can be any number from -infinity to +infinity as an answer. So the domain inverse of tangent inverse is going to be -infinity to +infinity. Where we get ourselves in trouble is the range. When we have the range, what we want to be able to do is plug something into our calculator and get one right answer out of it. The problem is, if you look at sine, if I plug in a 1/2, there are infinitely many things where sine is equal to 1/2. If I put in a 1/2 here, you can see there are infinitely many angles that have a sine of 1/2. Look at that. There's infinitely many of these things. So we don't want infinitely many answers. We want one right answer. So the way that mathematicians decided to sort of fix this is they said, all right, what is the smallest chunk of sine that we can look at, preferably around the angle 0, that will give us all the way from a y of -1 to a y of +1? And they did that by looking at this highlighted blue section. So you can see what I've got highlighted in blue is from an x of -π/2 to an x of +π/2. And that gives us the y values from -1 to +1. So they took that bit and they said, all right, let's just take our answers from this little bit of the graph. So we're only going to take our answers for sine inverse from -π/2 to +π/2. So then this is a graph of sine of x. So what does the graph of sine inverse look like? Well, when we switch the x's and y's, this is what we get. Notice what we're plugging in are x's from -1 to +1, and the answers that are coming out are -π/2 to +π/2. So the range of sine inverse is going to be from -π/2 to +π/2. Those are the numbers that are going to come out as answers. Now, notice -π/2 is down here. Remember, if you're looking at a unit circle, negative goes in this direction, down here to the negative. So this is our negative angles right here in this portion. And then our positive angles will come from this portion of the unit circle. So what quadrants are we really looking at our answers coming out of? Well, our answers are coming out of quadrants 1 and quadrants 4. I know this is kind of confusing, but once we get started on the problems, this will make a little bit more sense. But we have to kind of pull all these nitty-gritty things together. So we're going to get answers from quadrant 1 and quadrant 4, and the quadrant 4 answers will be negative angles from -π/2 to 0. Okay, let's take a quick look at cosine and see what's going to happen there. So if we look at the graph of, let's look at cosine. Here's a graph of cosine. If we look at the graph of cosine, you'll notice that from 1 down to -1 happens in a slightly different way. That all isn't centered around the x-axis anymore, but it's that first portion of the x-axis from 0 to pi. So this is where we see a y value from -1 to +1, and we are using angles from 0 to pi. So when we flip this and we say, okay, what does cosine inverse look like? Well, it looks like this, where you can see we go from x's of -1 to 1. Those are the x's we're plugging in, and look at the y values. The y values coming out are 0 to pi. So if we look, what are the range? What are the answers that are coming out of cosine inverse? Well, those are angles from 0 to pi. What is 0 to pi? Well, that's quadrant 1 and quadrant 2. If we look at our unit circle, quadrant 1 to quadrant 2, that is 0 to pi. So all of our answers will be coming out of there. All right, let's look at tangent. So here is our graph of tangent. You can see it's the same thing repeated over and over and over again. But we can focus in on just one of these little pieces. And the easiest piece to focus in on is the one right in the middle from -π/2 to +π/2. So they said, let's not do all of them. Let's just look at this little middle piece and let's do our inverse trig, our inverse tangent from this little piece. So what does that look like when we do the inverse? Well, it looks like this. Notice the x's are going from negative infinity to positive infinity. But what are those y values that are coming out? Those are going from negative pi over 2 to positive pi over 2. So we can plug any number we want in for tangent inverse. And the answers that are coming out are from negative pi over 2 to positive pi over 2. So this one is a lot like sine. The only difference here is that if you look at the unit circle and you try to do the tangent of, say, pi over 2, so it would be sine over cosine. Well, what is 1 divided by 0? Does not exist. So the tangent of pi over 2 and negative pi over 2 don't exist. So when we look at our answers here, we're not going to include those endpoints. So what are the quadrants that we're going to be looking in for answers? For tangent, we're going to be looking at quadrant 1 and quadrant 4. And again, those quadrant 4 answers are going to be negative answers. Okay, in summation, what did we just learn? This is a lot of information, but it's very important. When you are looking at y equals sine inverse of x, remember what you're plugging in is a number between -1 and 1 for sine, and the answer that is coming out is an angle. Okay, what are those angles allowed to be? They're allowed to be from negative pi over 2 to positive pi over 2. So our answers are going to come from quadrant 1 and quadrant 4 of the unit circle, where the quadrant 4 answers must be negative angles, not positive angles. Similarly, in cosine inverse, we're going to pull our angles from quadrant 1 and quadrant 2. Those are all allowed to be positive. And tangent inverse, we're going to look for those answers in quadrant 1 and quadrant 4. And again, our quadrant 4 angles will be negative.